Hey everyone, welcome back to yet another fun and exciting pre-calculus class. Today we will be starting on chapter number 3. What you'll see there on chapter 3 is it talks about angles on the Cartesian plane. So you might think that's kind of a jump away from what we've been doing, and you're kind of right and you're kind of wrong, because what you're going to see is pretty soon we're going to start drawing triangles on the Cartesian plane, right triangles specifically, and using sine, cosine, and tangent to do that. So what we have to do is kind of bridge that. We've been doing the triangles. We're going to take a second, and now we're going to talk about the Cartesian plane and how we can get them from, I guess, just a white space onto the Cartesian plane and how that looks. All right, so I'm not going to insult your intelligence here and act like you don't know anything about the Cartesian plane. I am actually going to rely on the fact that you have had Algebra 1 and you have had Algebra 2 and you have had geometry. And so we won't talk about a lot of the basics of the Cartesian plane, but I do want to really kind of just review one thing. And that is, real quick, before we really get started with the lesson, I just want to go back over the quadrants. And so let's look at this right here. Don't pay any attention to this initial side, terminal side. We'll get to that in just a second. So let's go through and let's just kind of mark down and let's talk about the quadrants real quick. Don't forget that this is quadrant number 1. In quadrant number 1, all of the values, both the x, this is the x line, and this is the y line up here, and it kind of looks like another x, so we'll try to do that a little bit better. And that's the y line. And so both coordinates on in area 1, both coordinates are positive. So you'd have positive, positive in coordinate number 1. In quadrant number 2 here, you'll remember that we're going to the left on the x, so that's going to be negative on the x coordinate, and we're still going up, so it's going to be positive on the y coordinate. So that's quadrant number 2. Down here in quadrant number 3, we're going negative on the x, so we're going left on the x, and we're also going down on the y, so this becomes our negative, negative. Now, let me just take a really quick second right here and just kind of teach you something that is kind of important here with what we're doing. Quadrant 1 is a positive quadrant, right? Well, that's easy to see because it's positive, positive, okay? Now, in algebra, you learned that when you have two negatives, what do you have? That kind of looks like a smiley face right there, right? Okay, I digress. But when you have a negative, negative, what do you have? Well, you have a positive. Two negatives make a positive in algebra. So this is a positive quadrant up here, and this is a positive quadrant down here. 1 and 3 are positive quadrants. So if your slope is going like this, it's positive. If your slope is going like this, then it's negative. Why? Because quadrant 2 is a negative quadrant, and quadrant 4, which we're going to get to in just a second, is also a negative quadrant. So that's kind of important to kind of wrap your mind around here as we're going into this. And so the next one is obviously number 4, and we're going right on the x, so the x is positive, but we're going down on the y, so the y is negative. So this is going to be a positive negative quadrant, which comes out to be a negative quadrant overall. Okay. All right. So I wanted to show you that. And again, I'm not going to insult your intelligence by going any deeper into it. I just want to review that, because if we don't have that, if we don't remember that, then we're really going to be struggling to learn the next few parts here. Okay. All right. So angles on the Cartesian plane measured in degrees. So now what we're going to be doing is putting angles on our Cartesian plane. And when we do that, you're going to see some different things occurring. So if you look at your book, you'll see figure 3A. In figure 3A, you're going to see something called a positive angle and a negative angle. Maybe you didn't know that there was such a thing as a negative angle. All right, so let's first of all start with, let's see, you can see here where it says the beginning side right there is the initial side, and the ending side is called the terminal side. So I want to kind of address that before we go any further. So what does that mean? Look over here, and you will see that the beginning side is where the angle begins. I'm going to put the beginning side here in green. This will be the initial side. So we're going to start right there at origin, and we're going to bring it this way. Okay, so that's our beginning side. That's our ray that begins our angle. Now the terminal side, I'll make this yellow so you can see it. It's where it ends, okay? And I'll actually do several different terminal angles, but let's start with this. So if you can see here, this is my yellow side. This is my terminal side. So wherever I want to put it, that's where the angle is going to end. So you have the beginning side, the green line, and the ending is the yellow line. Now, why is the green line the beginning? Well, in trigonometry, the initial side is always on the x-axis. It always falls. You always turn your angle. So let's say you're taking your angle from off of the Cartesian plane and you're putting it onto the Cartesian plane. You would always line up one of the sides, your initial side would always line up on the x-axis at 0 degrees. Okay, so that's where your angle has to start. That is very important, that this green line right here, that it be on the x-axis. It can't be, you can't start it wherever you want. It has to start at origin and go, the initial side has to go down the x-axis in the positive direction also. So you're going to 0 degrees. So this would be on the Cartesian plane, this would be 0 degrees right here, okay? And so that's the initial side. You have to have that. Now, the terminal side can really fall anywhere on the Cartesian plane. Obviously, it has to start at 0, 0. So it has to start at the vertex of the angle, but then it could go anywhere on it. I mean, theoretically, you could have one. I'll do another one here. I'll put it in a different color. So we're starting here at the initial side, and we could go over here. We could go down here. We could go down here. It could go anywhere in this. Okay, and it can actually wrap both in positive and in or in clockwise and counterclockwise directions. So what do I mean by that? Well, going this way that's the way the clock goes, right? You know, 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. Okay, so that's the way the clock goes. That's called clockwise. Then you could also go what's called counterclockwise. Okay, and so we're going away from, so now we're at 2 o'clock, 1 o'clock, 12 o'clock, 11 o'clock. So now we're going counterclockwise. So there's two ways to wrap around this thing. And you're saying, what do you mean by wrapping around it? Well, it's kind of like the hands of a clock going around in circles, okay? I want you to think about something. I just put that here where I put 0 degrees here. So I said, okay, that's 0 degrees. I want to show you something, though. If I take and I wrap my angle all the way, that's a terrible circle, but if I wrap my angle all the way around there, what have I made? I've made a circle. So it's 0 and 360. It's actually both because it's starting and stopping where the circle forms. So you're starting the circle and ending the circle. So it can be a 0 degree angle. This could also be a 360 degree angle because it also ends the circle. Okay, so that's kind of important to understand too as we're going into this. All right, so I'm gonna put these on this yellow one. Let me get rid of that yellow one for a second. I'm gonna put it on there again. So if we go counterclockwise, so if we're going kind of up to start, remember that this is a positive quadrant, right? This is the positive, okay? So if we're taking our terminal side and we're putting it into this is a positive quadrant, okay? So this is going to be going into, this is the positive direction, okay? And I know at a certain point you turn and you go negative, but this is the direction you start. You go counterclockwise to start your angles. So let's say that I want to draw a 60 degree angle, okay? Well, I would start at 0, okay? And I would go up until I got to my 60 degree angle. Now, I don't have anything to measure it, so I'm just kind of putting it somewhere on there. But let's call that 60 degrees. Let's say that that's 60 degrees, okay? That is a positive 60 degree angle right there, okay? Now, We could also go down on this Cartesian plane, and we could have what's called a negative angle. Why is it negative? Because right now we're going in the negative direction. We're going down. And so I could open that up 60 degrees. And so this could be a negative 60-degree angle because I went down 60 degrees. Okay? So you can have positive angles, negative angles, and you can even go more if you want. So let's say that I went here, and I started going around, and I got to 90 degrees, and I kept going. And I don't know what we'll call this. We'll just call this whatever. We'll call this 120. Call this 120 degrees. And that would be a positive 120 degrees. We could put another one on those, put one more on there. And let's go now into the third quadrant all the way over here. And I'm just going to call this, I don't know, we'll call this 200. And I know it's probably not lining up perfectly for those angles, but I just want to show you. And that would be a positive 200. Now, let's go ahead and erase these angles, except for that 60. And I want to show you a couple different things here with this. Let's look down here at what's called coterminal angles. Coterminal angles are angles whose terminal side coincides. What does that mean? Okay. Well, they terminate on the same point. All right. So let's kind of go back to this one just a little bit, and let's say that we have, I'll put one in this blue color here. Let's say that we have one at 60, all right? And then we have an angle, and this might blow some of your minds what I'm about to do. We have an angle that wraps all the way around and comes back to 60 again. So that one wrapped all the way around. So what would that be? Well, that would be 360 plus 60. Notice I went all the way around plus back to my 60. Okay, so that's a 360. That's a one circle plus 60 more. So we would add those together. So we would get 420. That circle would be, or that angle. So this would also be, the blue one would be a positive 420. So that one's, it's a coterminal angle. So notice 60 is coterminal with 420. Okay. Now, really about to get your mind blown now. Well, first of all, because I'm running out of colors to use, but I'll just go to this white color. You'll be able to see it. So now I'm going negative. Okay. Negative 90, negative 180, negative 270, negative 300. I'm back on my coterminal angle again. Now, this time I have a negative 300 degree angle. You're like, whoa, negative 300. Yes. Okay. Because I went all the way around and it's negative 300. You say, how did you figure that out? Okay. I'm glad you asked. There's a little formula in your book. Let me jump over here to the book real quick and show it to you. So a little formula right here that says mathematically it is written n plus minus n times 360. What is that? That's how you calculate your coterminal angles. That's how you figure that out. So let's jump back over here to this screen and let's look at this. Let's kind of prove it mathematically. When we went back up here, we said, okay, one of our coterminal sides is 420, okay? So let's prove that using this formula that we just learned. Let's prove that it is indeed coterminal with 60, okay? And so what we'll do is we'll come down here and we're going to plug into this formula right now. What was our theta? Well, our theta that we're trying to prove is the 420. So we're trying to prove that 420 is coterminal with 60. So 420. And then we're doing plus minus. And I'm going to keep the plus minus there for just a second because I want to show you this n first. Then I'm going to show you how to figure if you're doing plus or minus. Okay. And so what is the n? If you look over here, the n is the number of revolutions. What does that mean? Well, if this is our Cartesian plane, it's the number of times we're spinning around the Cartesian plane. So if we spin around it one time, then it's 360. If we spin around it 2 times, it's 2 times 360. If we spin around 3 times, it's 3 times 360. Okay? And we can spin around that thing as many times as you want. We can just keep spinning around the circle. You could do it 10 times, 20 times, all right? But for this case, 420 is 1 revolution. If you remember right, when I went back to this one, this blue one that I did, okay, I did 1 revolution, and then I came back to that spot. So that was 1 time around the circle. Now, what if I did 2 times around the circle? Okay, well, that's something different. That's a different angle. So you'd have to add 360 twice. But for this one, we did it 1 time. So we're going to do 1 times 360. Okay, so 1 times 360 is 360. Now, here's the question. Do I add or subtract to this? Well, you are going to subtract this one. Why? Because you are trying to get it to the 60-degree angle. You're trying to get it within the 360. So what you're going to do is you're going to do 420 minus 360, and you're going to borrow, and you're going to get 12, and you're going to get 60 degrees. There it is. We just proved our coterminal angle to 420 is 360. Now, we can do the same thing. Let me get rid of some of this. We can do the same exact thing with our other one that we had. What was the other one that we had? Negative 30. Okay, so we said, oh, negative 30. No, that was negative 300. Sorry. I think I must have erased a 0. There we go. Negative 300. So let's try negative 300 in that spot. So what is our theta now? It's negative 300. Plus minus. In this case, we're going to be adding, because we got to get it wrapped into the circle, 360. Again, 1 times 360, because we only did 1 wrap, and so it's 360. Now, you're just going to do this. How do you do this in algebra? Well, you subtract 300 from this, and you get 60, and this is bigger, so it's going to be positive 60. So there it is. We just proved it again. A negative 300 degree angle, it's coterminal with a 60-degree angle. Okay. I think that's about everything from this lesson. Let's jump over here real quick to this page. We'll do one of these examples, and then we'll be done. Find 1 positive and 1 negative angle coterminal with this. So now this is kind of like a little bit backwards, I guess, if you will. So what we're going to do is we're going to use 45 as our coterminal. And so we're going to use this, and so we're just going to plug back into our formula again. So we're using 45. All right, so let me erase some of this stuff. And now it's kind of like we're wanting to find something that it's coterminal with. Okay, so we'll use 45 as our theta, and then we're going to add 1 times 360. We could do 2 times 360 too, but let's just do 360. So we're just going to add 45 and 360. And that's going to come out to 405. One angle that's coterminal with that is 405. You could also do 2 times 360. 2 times 360. So what are you going to get there? You're going to get 720. So another terminal angle you could do would be 45, add to that 5, 6, 765 is also coterminal with that. So that's another way to do it. But then it asks you also to find a negative angle that's coterminal. So now we're going to do the subtraction. So 45 minus 360. And so 45 minus 360 is kind of a little bit backwards. And so what we would do is we would just subtract here 45. You can do this on your calculator too. It's fine. 315, and that's a negative 315. So negative 315 would be our other one. So just plug into that little formula. It's as easy as it comes, right? So every once in a while, I try to, give you an easy lesson. So a little bit longer because I really wanted to get some of that stuff in there to you. But really, when it boils down to it, you're just wrapping around that circle and you're just plugging into the formula to get your coterminal angles. What does that mean? It means that the terminal side is lining up on the other terminal side. And that's what we're looking for. Next lesson, we'll kind of take it to the next step. Okay? Well, that's all I got for you. Hope you have a good one. Bye-bye.